Um, Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Nuclei. So any doubts if you have in any steps, then please write that in the comment section. We shall obviously clarify them in the subsequent videos or in any other chapter of physics. If you have more difficulty, then also mention the name of that chapter in the comment section, so that we can give more priority on it and solve more and more questions on that chapter. Uh, Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told a count rate meter shows a count of 240 per minute, 240 counts per minute from a given radioactive source. 1 hour later, so it is the activity A naught, means at t equal to, so it is the initial value of activity at t equal to 0. So then 1 hour later, the meter shows a count rate of 30 per minute. So it is the at time activity at time t equals to 1 hour. 1 hour means at 60 minutes. The half-life of the source is, so now therefore the half-life of the source t half, that is given as ln2 by lambda, where lambda is the decay constant. Lambda is the decay constant, and we know that activity A equals to A naught e power minus lambda t, A naught e power minus lambda t. So therefore activity is 30 per minute. There's an A naught is 240, 240 into minus lambda into t. So t here, t is 60 minute. So t is 60. So therefore we can say that 30 divided by 240, that is equals to e power minus 60 lambda. Therefore 3 8s are 24. So it means e power minus 60 lambda, that is equals to 1 by 8. So it means 60 lambda, that will be equal to ln 8. Means minus 60 lambda will be equal to minus of ln 8. So minus minus I can cancel out. So now lambda is equals to ln 8 by 60. Therefore lambda is equals to ln 8, I can write 3 ln 2. 3 ln 2 divided by 60. So that is 60. So that is ln 2 by 20. So therefore half life will be equal to ln 2 by lambda. So that will be equal to ln 2 by ln 2 by 20. So that is equals to 20 minutes. So 20 minutes is the half life of the source. So option 1 is the correct answer. Then here it is told heavy water is. So heavy water is called as D2O. Means here instead of uh, hyd hydrogen, the heavier isotope of hydrogen, which is H12, which is called deuterium, is used. Heavy, the heavier isotope of hydrogen is used. So this D2O, D2O is called as heavy water. So it is a compound of deuterium and oxygen. So option 3 is the correct answer. The nuclear reactor at Kaiga is. So Kaiga is a nuclear reactor in Karnataka, and it is a power reactor. Power reactor. Since why the uh, this nuclear reactor is used to supply electrical power. Then here it is told consider two nuclei of the same radioactive nuclide. One of the nuclei was created in a supernova explosion 5 billion years ago. The other was created in a nuclear reactor 5 minutes ago. The probability of decay during the next time is, so the probability of decay of decay, that is proportional to the decay constant which is lambda. So we know that lambda, or the half life, which is equal to ln2 by lambda, these values are constant, and it is independent of the time at which the radioactive nuclei is created. It is independent. So it is independent. So it is independent of the time of creation, of the time of creation of the radioactive nucleide. Radioactive nucleide. So, the probability of decay is also independent of the time of creation of the radioactive nucleide. So it means option 4 is the correct answer. Then here it is told mean life of a radioactive sample. Mean life, it means the average life. So that is equals to 1 by lambda. And the half-life, that is given as ln2 by lambda. So 1 by lambda, here it is given as, here the mean life, or the average life, that is given as 100 seconds. So the half-life, that will be ln2 by lambda. So it will be ln2 times the mean life. That is, so ln2 is actually 0.693. 0.693 into 100 seconds. So that will be 69.3 seconds. Or we have to, here the half-life is asked in minutes, so it will be 69.3 divided by 60 minutes. So it is approximately slightly more than 1. So it is 1.155 minutes approx. So option 4 is the correct answer. And here it is told 2 nucleons are at a separation of 1 Fermi. The 2 nucleons are at a separation of 1 Fermi, means 10 power minus 15 meter. The protons have a charge of 1.6 into 10 power minus 19 coulomb. The net nuclear force in between them, is F1. And if both are neutrons, neutrons, and if the separation D is kept same only, which is 1 Fermi, then also the force is F2. And if a neutron and 1 proton is having the same separation of 1 Fermi, then also the nuclear force in between them is F3. So here we know that the rule is that the nuclear force is independent of the type of nucleon. The nuclear force, or the magnitude of the nuclear force, is independent, so it is independent of the type of nucleon. So it means that even if both are neutrons or both are protons, or one is neutron and one is proton, then also the force will be the same. The nuclear forces in between them will be the same only. F1 is equal to F2 will be equal to F3. So all three will be same. So option 2 is the correct answer. Then here it is told the activity of a radioactive sample decreases to one-third of its original value in 3 days. So here it is told, so we know that activity equals to A naught into e power minus lambda t, where lambda is the decay constant, A naught is the initial activity of the radioactive sample, and A is the activity at any time t, activity at time t. So it is the radioactive decay law, we can say. So then here it is told the activity of a sample decreases to one-third of its original value in 3 days. So it means A naught by 3 will be equal to, so at t equals to 3 days, the A will be equal to A naught by 3. It has been told. This has been given. Then in 9 days, the activity will be how much? So A naught by 3 equals to A naught into e power minus lambda into 3 days. Therefore, A naught will cancel. So then we can say e power minus 3 lambda, that is equals to 1 by 3. So therefore, 3 lambda will be equal to ln 3. Therefore, lambda equals to ln 3 by 3. And the unit will come in days inverse per day. So therefore, in 9 days, the activity will be how much? So at t equal to 9 days, the activity, let's suppose A dash will be how much? So A dash will be equal to A naught e power minus lambda. Lambda is ln 3 by 3 into t, t is 9. So that will be 3, 3 is a 9. So it is A naught e power minus 3 ln 3. So, or we can say A naught e power minus ln 3 power 3 means 3 9s are 27. So therefore, A dash is coming A naught into, so this we can write e power ln 1 by 27 means it is 1 e power, and the rule is e power ln into something e power ln x, that is equals to x. Okay, it is the rule. So therefore, we can say A dash will be equal to A naught by 27. So it is, so at t equals to 9 days, the activity will be 1 by 27 times of the initial value. So option 1 is the correct answer. Then here it is told if R1 and R2 are the radii of the atomic nuclei of mass numbers 64 and 125 respectively, then the ratio R1 by R2 is. So we know that the mass of a nuclei, that is equal to the density of nucleus into the volume of the nucleus, So the mass is uh, proportional to the mass number of the nuclei. So we can say A, that is equals to, and the assumption is rho is the density of the nucleus, which is assumed to be constant. Density of the nucleus, which is assumed to be constant. So then A will be equal to rho times 4 by 3 pi r cube if we assume the nucleus to be a sphere. So therefore, we can say that A is proportional to r cube. The mass number is proportional to the cube of the radius of the nucleus, or you can say the radius of the nucleus is proportional to A to the power 1 by 3. So therefore, R1 by R2, that will be equal to A1 by A2 power 1 by 3. So here A1 is the mass number of the first nucleus, which is 64, and A2 is the mass number of the second nucleus, which is 125, whole power 1 by 3. So that is equal to 4 cube divided by 5 cube whole power 1 by 3. So that is equal to 4 by 5. So it means option 4 is the correct answer. Then here it is told an electron is a lepton, a nucleon, a baryon, and a hadron. So nucleon means those only proton and neutron. Only proton and neutron are called nucleons. Since why they are present inside the nucleus of an atom only. Electron is not a nucleon since why it is present outside the nucleus of an atom. And lepton, the examples of leptons are electron, electron, uh, muon, okay. The examples of lepton are electron, muon, and neutrino. These are called leptons. Since why they are not affected by strong nuclear forces. They are not affected by strong nuclear forces. So it means, and baryon, it means they are also of two kinds. One is mesons and one is, okay, no, hadrons. Okay. Hadrons are of two types, mesons and baryons. Mesons, the examples of mesons are pion and keon. And meson, it means uh, they are formed by quarks. They are formed by quarks and antiquarks. Quarks and antiquarks. And examples for baryons, they are proton and neutron, or you can say anti-proton and anti-neutron. And leptons, one more example is anti-neutrino. Anti-neutrino and anti-electron, or it is also called positron, etc. Okay. So, so it means that an electron is a lepton. So it means option 1 is the correct answer. Then here it is told the volume of a nucleus is directly proportional to. So we know that the radius of a nucleus is proportional to the cube root of the mass number. Cube root of the mass number of the nucleus means A power 1 by 3. Now the volume of the nucleus is equals to 4 by 3 pi r cube if we assume it is a sphere. So that will be proportional to the cube of a power 1 by 3, or I can say a. So it means the volume is volume of a nucleus that is proportional to the mass number. So option 4 is the correct answer. Then it is told a, a radioactive substance, it contains 10,000 nuclei. 10,000 nuclei it contains, and its half-life T half, that is equals to 20 days. Then the number of nuclei that will be present at the end of 10 days is. So at t equals to 10 days, how many nuclei will be remaining? So it means the initial number of nuclei is 10,000. It means, therefore, decay law, according to according to the radioactive decay law, according to the radioactive decay law, we have n equals to n naught e power minus lambda t. Therefore, at t equals to 10 days, we have to find how many nuclei will remain. So we know that the half-life, that is equals to ln2 by lambda. So that is given as 20 days. So therefore, so we can say lambda will be equal to ln2 by 20 days inverse per day, it means. Now therefore, at t equals to 20, t equals to 10 days, we can say n will be equal to n naught, which is 10,000, e power minus lambda, which is ln2 by 20 into the t, that is 10 days. So 10 2 will cancel, so it is 10,000 into e power minus half ln2, so which is 2 power half. I can say this will be 10,000 into e power ln 1 by root 2. It's 2 power minus half means 1 by root 2. 1 by root 2 obviously. 1 by 2 power half means 1 by root 2. So, and we also know that e power ln x, that is also equal to x. So therefore this will be 10,000 divided by root 2. So therefore the number of nuclei at t equals to 10 days, that will be equal to 10,000 divided by root 2, or you can say 10,000 by 2 into root 2. Now root 2 by 2, root 2, root 2 by 2 is how much? Approximately that is 1.414 divided by 2. So that is 0.707. So therefore, the number of nuclei at t equals to 10 days will be 0.707 times 10,000. So that will be equal to 7070. 7,070 nuclei will be present at the end of 10 days. So therefore, option 4 is the correct answer. A radioactive element forms its own isotope after 3 consecutive disintegrations. The particles emitted are. So it means that a radioactive nuclei XZA goes into, suppose, so if the particles emitted are 2 beta particles, so it means that 2e minus 1 0 plus it will form some y z plus 2 and a, plus it will give out okay, 2 consecutive disintegrations. It will give, let's say, neutrino, anti-neutrino. Okay, so then and again it will go to e minus 1 0. Now this electron is called as the beta minus particle, and plus, let's say, some, it gives b, say it gives some x dash z plus 1, this will be, then this will be z plus 2 a antineutrino, and then again it will give another alpha particle. So again it will, so if it gives out alpha particle which is He24, this is called the alpha particle. Then again it will form xza minus 4 plus something will get forgot. So it should give two beta particles and one alpha particle. Then only, since y, it has to give its own isotope. So it means the number of protons should remain the same. The number of protons or the atomic number, which is z, should be the same. So it means that it should give out two beta particles and one alpha particle only. So option 3 is the correct answer. Then here it is told the radioactive sample has a half-life T half of 3 years, and the time required for the activity of the sample, to reduce to 1/5 of its initial value. So let the initial activity is A naught. A naught is the initial activity, and A is the activity at time t, activity at some time t, which we have to find. Okay. And we also know that A equals to A naught e power minus lambda t. A naught e power minus lambda t, which is the radioactive decay law. Radioactive decay law. So from here we can say that A naught by 5, that should be equal to A naught into e power minus lambda t. Now, t half, the half-life is equals to 3 years, which is also given as ln2 by lambda. That is equals to 3 years. So therefore lambda equals to ln2 by lambda. No, sorry, ln2 by t half. ln2 by t half, that is equals to ln2 by 3 in year inverse, means per year. So therefore this will be a naught will cancel. So I can say 1 by 5, that is equals to e power minus lambda. Lambda is ln2 by 3 into t. So if we take ln on both sides, then we will get ln 1 by 5, that is equals to minus ln2 and ln2 by 3 into t. Therefore ln5 minus ln5, that is equals to minus ln2 by 3 into t. So minus minus will cancel. So from here, so this is ln, yeah. So therefore we got ln5, that is equals to t by 3 into ln2. T by 3 into ln2. So therefore, you can say 3 ln5, that is equals to t ln2. So therefore ln5 power 3, that is equals to ln2 power t. So therefore 2 power t, that is equals to 5, this is 125. So t equals to, I can write, this log 125 base 2. Log 125 base 2. So therefore t we can also write, this is log 125 by log 2. So this will be log 125 means 3 log 5. 3 log 5 by log 2. 3 log 5 by log 2. So this is 3 into log 5. Log 5 is 0.7 by log 2 is 0. Log 2 is 0.3. So point will go away. So 3 will cancel. So it is 7 years. So at t equals to 7 years, its initial value, its activity will reduce to 1/5 of its initial value. So option D is the correct answer. Then here it is told a nucleus with mass number, a nucleus having mass number A 220 Initially it is at rest initially. It emits an alpha particle. It emits an alpha particle. If the Q value of the reaction is 5.5 mega electron volt, then calculate the value of the kinetic energy of the alpha particle. So the nucleus is at rest. Then what will happen? It will disintegrate into alpha particle, means He24. So it means that it is having X, Z, A, suppose. Okay, the mass number is 220. Mass number is 220. So here it will give out Y. Y will be a Z minus 2, and mass number will decrease by 4 units. So that will be 216, since YA is 220 here. Then and it will give out one alpha particle. So it means the net momentum will be conserved. So here we have to apply the conservation of momentum. So here we can say, let's say its mass is m1, mass of the alpha particle is m2, suppose. So if we apply the conservation of momentum, then we will have m1 v1. Let's say its velocity is v1, here its velocity is v2. So m1 v1 minus m2 v2, that should be equal to 0. Since why, the initially the nucleus was at rest, so the initial momentum of the system was 0 only. Initial momentum of the system, that was 0, and the final momentum also should be 0 only. So therefore I can say m1 v1, that should be equal to m2 v2, or m1 is 216 v1, that should be equal to 4 v2. So therefore v2 is 216 divided by 4 v1. So that will be 4 5s are 20, 4 4s are 16, 54 times v1. So now therefore the q value will be equal to the kinetic energy, the sum of the, so this q value will be distributed among the among this new daughter nuclei which is formed and the alpha particle. So this q value will be equal to the final kinetic energy of the nuclei 1 which is formed, and plus the kinetic energy of the alpha particle. So Ke1 plus Ke2. So which will be equal to half m1 v1 square plus half m2 v2 square. So here we have to find the kinetic energy of the alpha particle. It means Ke2 we have to find. Kinetic energy of the alpha particle, that we have to find. So now therefore let the kinetic energy of the alpha particle, that is kinetic energy 2, that is equal to, suppose, that is half m2 v2 square. That we have to find. So that will be equal to half into 4 into v2 square. So that is 2 v2 square, that we have to find. That we have to find out. Okay. And so the kinetic energy of the nuclei 1 which is formed, which is nucleus y, so that will be equal to half m1 v1 square. That will be equal to half into 216 into v1 square. And here we have also found that v2 equals to 54 v1. So it means that v1 equals to, okay, v2 equals 54 v1. So v1 equals to v2 by 54. v1 equals to v2 by 54. So that is half It is 108, 1s are 2, 2 is 16, into V2 by 54, V1 equals to V2 by 54, so V2 square by 54 square, so 54 into 54. So 54 2s are 108. And 2 2s are 4, 2 7s are 14. Okay, so this is V2 square by 27. Now therefore the Q value will be equal to the kinetic energy 1, which is V2 square by 27, plus the kinetic energy of the alpha particle, which is V2 square. So this will be equal to V2 square into 2 plus 1 by 27. So that will be equal to, so we can also say this is equal to 2V2 square, 2V2 square into 1 plus 1 by 1 by 54. So this is 54 plus 155, 55 by 54. So this is 55 by 54 times 2V2 square, and 2V2 square is kinetic energy of the alpha particle, and which you have to find. So therefore kinetic energy of the alpha particle, that is 54 by 55 times the Q value. So that will be 54 by 55 times the Q value, which is 5.5 mega electron volt. So if we cancel it, this will be 1.1. No, this is 0.1 only. So 54 into 0.1, that is 5.4 mega electron volt. So 5.4 mega electron volt is the kinetic energy of the alpha particle. So option D is the correct answer. And here it is told, in the following equation representing beta minus decay, the number of neutrons in the nucleus X is, number of neutrons in the nucleus X is, okay. So bismuth 83 210, that is undergoing beta minus decay, so it is E minus 1 0. So it means the atomic number will increase by 1. So X will have the atomic number 84, and the mass number will remain the same, 810 plus anti-neutrino. So now therefore the number of neutrons in the nucleus X, that will be equal to 210 minus 84, since why mass number minus atomic number is the number of neutrons. So that is equal to 6, then 9, so 12, 9, okay, 9, 11 minus 9, 2, okay, so 126, 110 and 26 neutrons it will have. So option C is the correct answer. Then here it is told, in the Rutherford's alpha particle scattering experiment, as the impact parameter increases, the scattering angle of the alpha particle decreases or increases or remains the same, that we have to find. So here we have the gold nucleus, or suppose the target nucleus. So then if the alpha particle is incident like this with some uh, velocity v, this is the alpha particle. So then it will deflect. It's so the trajectory of the alpha particle will be like this. This is the trajectory of the alpha particle. It will undergo some deflection. So then this is called as the impact parameter B, and this is called as the angle of scattering, or the scattering angle. Now the rule is, if theta is the angle of scattering and if B is the parameter impact parameter and theta is the scattering angle, then we have that cot theta by 2 that is equals to K times the kinetic energy of the alpha particle. Let's say its mass is m, so it is half kinetic energy K into the half mv square by z square by where z is the atomic number of the target nucleus, and k this k is equal to 1 by 4 pi epsilon not only. Okay. No, sorry, this k I should write it here actually. It's kz is square by half, so this is half mv square by kz square into b. So it means what? From here you can see that cot theta by 2, it means I can say 1 by tan theta by 2. So that is proportional to b. It means that tan theta by 2 is inversely proportional to b. It means that when the impact parameter increases, the scattering angle decreases. Or if the if the impact parameter decreases, then the scattering angle increases. So here it is told if the impact parameter increases, the scattering angle will decrease. So option A is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter nuclei. Still any doubts if you have, then please write that in the comments. We shall obviously clarify them in the subsequent videos. And please install our Sapience Education application also, where we shall upload some important homework questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.